This is week 4, reliability and validity for child development 320. This is probably two videos this week, so this will be the first of the two. So we're talking about reliability and validity, which is how we know that the measures we get, the values we get, the data that makes our studies, our investigations science, how we know we can trust them, okay? So let's dive right on in. So 4 different ways of evaluating validity in research. The first one is construct validity. So validity has to do with whether we're measuring what we really think we're measuring, right? So the adequacy of our operational variable or operational definition of a variable. And we've talked about this before in other classes. The operational definition, there's no one right answer for how to operationally define something, but you've got to be able to make a good argument for that being the way to define a thing. And it's got to be something that is measurable, observable, countable, right? Something that we can test, that we can see evidenced empirically. So for construct validity, this is one of 4 types of primary types of validity. Construct validity, we're looking at how well we define that variable. So in this case, I wanted to offer you guys an example of SpongeBob SquarePants and a study from a while back. I talked to you guys about this same example for as it was my example of pseudoscience in our first lecture. So if you remember, there was a study that was done looking at children's attention and their video watching, right? And some of the news about that study, one of the reports about that study suggested that the study had found that SpongeBob SquarePants hurts kids' brains. Okay, so the operational definition that was used for media in this study was watching a clip of SpongeBob SquarePants. So they were not looking at all different kinds of media. They were looking at this one clip, right? So if I want to figure out how watching movies affects kids' brains, affects kids' attention, which is what they were looking at in this particular study, looking at just SpongeBob is not a very good sample. It doesn't really get at everything, right? Another problem with this is that the headline read, "Hurts kids' brains." Well, changing kids' attention, is that the same as hurting kids' brains? Brains we usually think of as the organ, and changing kids' attention span is not irrevocably, it's not unchangeably forever and ever hurting the organ of your brain, right? So there's how we are defining the terms, especially in how it was communicated in the headline, is problematic. On the other hand, the study itself only looked at SpongeBob, and what they were really trying to get at is media in general. So that's a problem as well. So if we were going to operationally define media as SpongeBob, that's a problem with the construct. So it's how we've defined the main kind of topic of focus, right? If we're trying to look at media and we're defining it as SpongeBob, SpongeBob is not all media. Thank goodness. Okay, so the next type of validity is internal validity. Internal validity is the ability to draw conclusions about causal relationships from your data. So this is, can I understand the relationship between the number of passenger cars, Japanese passenger cars sold in the US, and suicides by crashing motor vehicles? Can I understand the relationship between those two variables, right, by looking at this graph, by looking at the study? Well, the answer there would be no, right? There's, just because these two things go together, just because they correlate, just because there's a relationship, doesn't mean that I can infer a causal relationship between the data. As you may have heard in other classes, and you'll hear over and over again in this class, correlation is not the same as causation. Just because things happen together, just because they appear at the same time, even if that's really regular that they appear at the same time, doesn't mean that one is causing the other. There could always be some third variable, there could always be all kinds of other things going on, right? So in this particular example, Japanese passenger cars being sold in the US and suicides from motor vehicles by driving your car into something to try to kill yourself. These are highly correlated. What gives, right? Like, does this mean that buying a Japanese passenger, like buying a Japanese car, buying a Honda is going to make you suicidal? Is it that people who are suicidal buy Hondas, right? There's not a relationship there. But some people have argued that there may be a third variable here, and that for years, may not be presently the case, but for years, Japanese passenger cars were slightly cheaper than models made in the US. So some of the cheapest cars that you could get in terms of how much it cost right off the lot or how much it costs used were Japanese passenger cars. So if you are having money troubles are highly related to suicidality. Again, we don't know if that one's a cause either, because of the fact that would be really not cool to study that in a truly scientific situation. Okay, you guys, we're going to take all your money and see if you feel like killing yourselves. You guys, we're going to leave you with your money and see if you feel like killing yourselves. Like, this is not ethical, right? So we're not doing that. But the internal validity question is, can I look at the data you're giving me and look at cause? Can that tell me a story about cause? In this case, not true. There's a neat website that I'll connect you guys to on Blackboard that has tons of these correlations. There's a lot of stuff that is highly related to other stuff, but no plausible cause between those two variables. External validity. So external validity, what we're talking about is, can this be generalized to other populations? To what extent, from the sample that we looked at, the small group of things that we looked at, can we look at what's going on in the larger world? Generally, in social science, we want to look at a small group and try to talk about a larger group. That's what we're doing most of the time, right? We rarely are able to interview all the people that we want to know about. If I want to know about young men in the United States, I'm not going to get to interview all of young men in the United States, right? But I could sample a few of them and say, okay, so I'm going to talk to these guys at Cal State Dominguez Hills, and then I'll see about what's going on with all men in the United States. We would have problems with external validity if I did it that way, because for external validity, I would be assuming that those guys that I talk to are like guys in the whole rest of the United States. One, they're college students. So if I'm only looking at guys at CSU Dominguez Hills, they're going to college, they work at college, they're college students, right? So that makes you significantly different from a lot of the other folks in the United States. Also, we live in California, around the Southern California area, very different from other parts of the United States. So can we say that those 40 guys that I interviewed at Cal State Dominguez Hills are like the rest of the world? Or the rest of the United States even? The rest of even California? Probably not. So that's what we're talking about with external validity, is what can we understand from the sample we looked at with regards to the bigger population that we're trying to understand. Okay, so the next one is conclusion validity. And this is, does the research draw reasonable conclusions based on the analysis of the data? And what we're looking at here is is it reasonable? Are the stats that we've done reasonable? Have we reached a reasonable conclusion based on the statistical analysis, based on our analysis of the data, right? So if I have a study where I survey folks and I find that 49% of undergrads at Cal State Dominguez Hills think that abortion should be legal. And then I say that the majority of young adults at Cal State Dominguez Hills think that abortion should be legal. That doesn't work, right? 49 is not a majority. Even if I have 49% and then I have two other options, sort of and no, I still can't say a majority agrees that abortion should be legal, right? It just, the stats don't support it, right? Just basic percentages. That's not what I found, right? So that would be conclusion validity. Okay, so how do we threaten or support validity? So some of the threats to validity, this is how adequately we measure our variable, right? Are our measurements good? And this has to do with both what devices we're using to measure. So is it a good survey? But also, is it a good operational definition? We test this looking at convergent validity. So things should look like the things they're similar to, right? If I'm trying to find a small mouse that looks like Pinky, the brain, the little character in blue with a blue background, and I've come up with that little dog on the left, that's pretty darn good. They are looking pretty similar, right? It should look similar to things that are like it. If I'm trying to understand how good a survey of people's gratitude is, right? Then I would expect that their performance on that survey for gratitude is going to look similar to their performance on another survey of a survey of joy, right? Because these are related. We know that people tend to be happier when they are remembering to be thankful for things, right? So these two should go together. They look the same, they should be similar. We also look at discriminant validity. So discriminant validity is that it should not look like other things that are different. And this is not the opposite. This is instead, it should not look at like things that are completely a different kind of thing, right? So if I, again, am looking at people's, trying to figure out if my survey about gratitude works, is it a good survey of gratitude, then I would expect it to have no correlation, nothing in common with a survey for whether people are Democratic or Republican, right? There's no rationale for these two things going together. I have no research to support that those two things would go together, so they shouldn't correlate, right? Should not be related. And the last thing here about validity that we'll talk about is reactivity. I always think of a mischievous little puppy dog when I think of reactivity. Reactivity of a measure is something that harms its validity because it means that people are aware of overly aware of the fact that they're being watched or that they're being assessed, right? So in terms of remembering the mischievous puppy, this puppy in the picture is not eating things out of the trash. It wasn't me. I didn't do it, Mom. On the other hand, you can tell from looking at the ground around him, he was eating things out of the trash. That was him, right? So the fact that you are watching him now, or that someone has entered the room, has made the dog stop the behavior, right? So the behavior was dependent on whether or not they were being watched. I've seen this a lot with kids, where when they don't think people are looking at them, they may be doing one thing, but when they think that people are looking at them, they do another thing, right? Adults do that too. So this is, reactivity is when your measurement changes or the scores change based on social desirability. I want to look good to the researcher, just the observer being present. Um, Physiological measures, sometimes the fact that I'm testing you physiologically can change you, right? So um, if I'm testing how fast your breathing is, people will start, and they know that I'm doing that, people will start to focus on their breathing, which tends to slow it down, right? So there's lots of ways of reducing reactivity. We can try to ask easy questions first, let people warm up. We can use observation, so where people don't know that we're watching them. This is a problem for asking permission to do that. We'll talk about that in a couple weeks. There's a couple different things we can do to minimize the problems with reactivity. Okay, so we're going to stop here, and then we'll go on to the next, we'll stop here, and then we'll go on to the next slides for reliability.